Hello, and welcome back to another exciting episode of whatever the heck this is. So just another coding problem for you. Gosh, this is gonna be boring, but if you really have a hard time, I don't even know. I don't even know where I'm going with that. So today's problem is called, I don't even remember. It's called deepest leaves sum. So the whole point being that we're given the root of the binary tree. We have to return the sum of the values of its deepest leaves. I know you can read. So just if you don't know, here's the root, right? It's kind of the root. And the deepest leaves would be going all the way down to these. And from what I understand, they have to be on the same level. If you heard that thunder, I'm just as scared as you are. There's currently a thunderstorm here, and I think the heavens are not too happy with this video. Stay tuned for more horrible jokes. Please don't laugh. So, I'm trying to figure out if I should use a while loop to do it iteratively, or if I should try and make a helper method to do it recursively. I guess I'll try with the while loop first. Hopefully the audio sounds a good bit better. I did get a new microphone from Christmas, for Christmas. I had to do a lot of things to Santa that I'd rather not talk about right now. But the important thing is that I've got it. I also got a really loud clicky keyboard, so if that is totally obnoxious and ruining the vibe for you, please just send me a personal email and we can talk about it. But geez. Alright, well, here we go. I'm super rusty, and again, full disclaimer, I'm horrible at these. I'm a very mediocre programmer, and I'm super rusty. So, you know, if you want to roast me or leave any pointers, both are equally appreciated. So I'm going to start with root equals. Actually, let me just say, I'm going to name this node, and I'll say node. So while this node has a left to right, basically while it can keep going, we are going to keep looping through. Now, you know what? On second thought, I may want to do this recursively. No. Oh, I don't know. Let me just try it. This will be a learning experience for probably both of us, maybe. So, okay. So, if node dot left equals, I guess I do want to keep track of the max depth, right? That's important. Let's just name it depth. Get some nice short variable names. So if node left, so if it has a left value, let's go to that left value. I'm going to increment the depth by 1. Okay, this is definitely not going to work iteratively, but I'm just going to go ahead and type out the bulk logic, and then we can go from there. Yeah, so we'll increase the depth by 1. And then, I guess, yeah, you know what? I'm just gonna switch to a recursive approach. So we're gonna define a helper function called help that takes all the same arguments, I guess. Let me just copy this. add another argument to keep track of the depth. So we're going to pass in the depth and our node. Jeez, I'm really struggling with this. I woke up super late and yeah, this is going to be a doozy. So I think we can start off with the same thing. Let's name this node. Well, I'm just going to retype it because I like being inefficient. Node, and then the depth is the depth. I'm going to say if node dot left, and then do something, and then if node dot right, do something, and then if I guess we could say if node dot left equals, is it null? No, it's none, yeah. And node dot right equals none. And then we are going to so I guess we can go back here. I guess to explain what I'm doing a bit. Alright, so for each node, we're going to check if it has a left or right and traverse those. And then finally, when we get to something like this, where it doesn't have a left and it doesn't have a right, then we're going to say the depth that we reached and I guess get the value of it. I wonder if there's a way I could do this all in one pass, or if I just return the depth once, like return the depth and the node value. But I guess let's go ahead. So if the node has a left, we're literally just going to call help. I guess we want to return help, and then with node.left. And then we're gonna increment the depth by 1. So depth, why can I not type +1? Node.left. I don't know why I took the time out of my day to type do something. And here we're gonna return help, depth +1, node.right. I guess that would make sense, because technically these two. Right, so if node.left, depth goes from 0 to 1, and then call it. And then it's basically just going to keep going left. So if left, so now the depth is 3. So we're going to return 3 and the value 7. And then it's going to pop all the way back to here, right. And then the depth for the original call should still be 0. It's going to go right. Well, actually, I'm sorry. I guess it would work its way back up, right? So it called left, none. It's going to check right, nothing there. It's going to check right, nothing there. It's going to check right, there is something. It'll still have the same depth. Then it'll go here. And then this will have none. So it'll return the depth and the value. So I guess, is that what I want to do? Just return depth and node.val. Okay, I just thought of a really stupid way, where what if I keep passing in a list that's keeping track of all of the max depth nodes. I'm gonna try it. It's gonna be stupid. It's not gonna work. But I I said, I feel like I have to suffer a bit before I go to the solutions and go, oh, of course, that was so obvious. How could anyone be so stupid? So we're going to pass in a list. Shoot, I don't know. I'm just going to name it deepest, darkest, deeps. Gosh, that's really long. Please don't make any "that's what she said" jokes. That's very immature. Okay. So, sure. Well, I guess that's not even what I want to do there anymore. So then here we're just going to I guess the deepest, darkest deeps. Oh my, I'm sorry. I thought that would be funny. That's just stupid. So we're going to name it leaves. Gosh. Now you guys get to watch me type leaves a whole bunch. I'm so sorry. Okay. So if we make it to the bottom, we're going to do leaves.append, and I'm going to give it a tuple, which is sort of like an ordered, not an ordered pair, but sort of like an ordered pair, and that it has two values. So we're going to give it no.val. Actually, let's give the depth first. Depth, no.val. So basically what that'll look like is it's gonna, like for the 7, oh that's right, I'm pointing with my fingers for the 7 here. It's going to look like a tuple with the depth, which wow, that was, sorry about that. Depth, which is 3, and the value, which is 7. And then in my fantasy, at the end, this list will magically be populated with all those tuples. You know what? Let me make it a dictionary. That'd probably be even better. No, that wouldn't work because, okay, excuse my confusion. We are going to make this a dictionary. It's going to be a dictionary with the key as the depth and the value as the list of values. Okay. So we're going to say if leaves depth equals sorry, I'm trying to figure out how to do this because I kind of need to instantiate each thing with a list. Because I don't think you can append to a non-existent list. I think it has to exist already. Alright, well, it's going to run slower, but we can just go ahead and do the tuple idea. Good job, me. You figured it out. So again, it's going to look like depth and no.val. So I'm literally just going to say depth leaves.append, and then we're going to make it a tuple, depth, no.val. Okay. Okay, so let's clear out all this garbage. Oops. Okay. Okay, so what I'm going to do is just create the leaves list, and this is definitely 100% going to work. And then I'm just going to call help, and then give it just going to put depth as 0 just because I don't like putting random numbers and stuff. Makes me anxious, you know. And then root. And then leaves. So let's walk through this one more time. There's no way in heckers that this is going to work. But, you know, we'll give it our darndest, right? So leaves is empty. Depth is 0. And we're going to call help and just pass it depth, root, and leaves. So the node is, nope, see, we screwed up already because I can't say that would literally just start at 0 every time. So we're going to say root equals root 0. Because I think the root is this list, which is kind of confusing terminology. We'll say node. I like the word node better. And then I really should figure out how to refactor the variables in whatever editor lead code uses. But we're just going to copy and paste. I'm not going to try to hit control save like I always do because it makes, I'll show you, since I've said it makes this thing pop up. And let's just not even mess with that. Okay, so it starts at the 0 index, or you know, the root, and then if it has a left, it increases the depth by 1, passes it the list of leaves, and goes to the left, and then that one will go left, and then left, and this one doesn't have a right or left, so it appends this depth and the value. Goes back up. Doesn't have a yeah, and I guess that would work because it does have a left, but it doesn't have a right. So that one should just end. Yeah, I mean, I guess that's okay that we're returning nothing, right? Yeah, well, we'll try it. And then no dot left, no dot right. So we're going to go right. And then this one doesn't have a left or right, so it's definitely a leaf. So we're going to append leaves. And then we go back to here. It does have a left, so that one should just end. I don't know if it needs to return anything. So go ahead and run it with the test, the sample. Wow, I'm shocked. I'm completely, absolutely shocked. Tree node object is not subscriptable. Okay, don't worry guys. I'm just stupid. Because it says root is... Oh, okay. I'm overthinking this. Yeah. So I'm trying to treat this like a list. I guess it literally just gives you this, and if I'm covering this with my hand, this bottom part here, but all it gives you is the 1, and then you just have to go from there. I guess that makes sense. What? It's defined right there, though. That's just so upsetting. Okay. Oh, it's because you can't define the helper function after you call it, because what kind of psychopath would do that? Okay, and then this will still not work, and then I'll be confused. Oh, you know why? It's because I probably have that stupid self thing there. It's still not gonna work. Yeah, that is so weird. Help. I know I'm doing something glaringly and horribly wrong. like I said, I'm just super, super rusty and probably should have picked an easier challenge. But, I don't know. Yeah, I don't know why I'm so confused about this. Do I have to put it outside of the class? I feel like this is just something really simple, and it's a little embarrassing that I'm tripping up on this, but that's fine, sort of, not really. It's not like I don't need a assignment, yeah. That's so weird. Oh wow, okay, so it ran. My output wasn't, because I'm a stupid idiot and I forgot to do the whole handling the, good job, me. Okay. So, this is about to be so inefficient. I know there's a smarter way to do this, I'm just dumb. So we're going to say for leaf and leaves, depth equals leaf 0, val equals leaf 1. I'm going to say, I'm going to name it deep, just to name the deepest depth. Yeah, there's gotta be, because right now I'm literally manually finding the maximum depth, but I feel like that's just a dummy way to do it. That's why I was trying to use the dictionary earlier, so I could just go straight to the max depth. Alright, well, you know what? I'll just do it this way, and then when everybody barfs because of how horribly inefficient the code is, maybe the solution will actually probably not work. Okay, so we're gonna say depth, and then if depth is greater than deep, deep equals depth. For leaf and leaves, depth greater than deep equals depth. We don't even need this. Oh my gosh, yeah, this is about to be painfully inefficient. And there may be pre-built functions to help with this, but whatever. So, yeah, I wish I could order it. If I was smarter, I would figure out a way to use the dictionary. But geez, we're about to loop through this whole thing again. If leaf 0 equals deep, and then we're gonna have a variable to keep track of the sum. We'll name it total, because sum is a keyword, apparently. We're gonna say sum sum plus equals, and then leaf 1. Okay, there's absolutely, if this works, I will physically eat my hat. Yeah. And then I'm still an idiot, because guess what we forgot to return? I'm doing that thing where I just randomly keep clicking the button and hope that it works. Okay. Well, at least we got an output. That's definitely something. Okay, so let's see what happened here. How did I get 7? Okay, just a crazy idea. I think I need to append the depth one more there. Nope, still getting 7. I wish I had this in VS Code or something so I could run through, like do the debugger mode and run it step by step, but I guess I'm supposed to use my brain for that or something crazy. Let's see. Alright, I mean, we'll start from the beginning. And then I've been at this for almost 26 minutes, so when it hits 30, I'll look up the solution because I feel like this was probably supposed to take about 5 minutes, but like I said, learning experience, no hard feelings. My Python's pretty rusty as far as like data structures type of programming. So, it's no dot left. Return help. Is it just adding the, how do I get 7 here? I mean 5 and 2, 3 and 4, the 6 and 1. Okay, I'm about to do some print debugging, and this is gonna be really gross. Print. Actually, let's just print out leaves at the end and see what is actually getting 2 leaves. So we're literally just going to print leaves. So all we're getting is 4 and 7. That is so weird. So 0 and 1, 2. Okay, well I guess technically this didn't need another one. I bet you it's because it's not returning. Yeah, I don't think it's working its way back up because I think it's just ending there. But it shouldn't, right? Alright, you know, I'm gonna concede. I think I used that word correctly. Let's just check out someone's 2-line solution, and then I'll go, wow, if only I was not so stupid. Okay, yep, here it is, and like, okay, I kind of hate when people code like this because it's hard for someone who's not that good to read it and understand. I always love the comments here because I feel like it's just me. People are like, okay, like dang, I see you, bro. And here we have a true homie making it really easy for all the dumb people like me. Okay, so let's check out his actual solution. See, so he did it iteratively because the guy's a genius. So pre-R nodes in the previous level, QR nodes in the current level. When the current level are empty, the previous level are the deepest leaves. Yeah, I mean that makes sense. So mal q. So pre q equals q. Yeah, I'm gonna be honest. That's gonna take a lot of brain work. So let's just go down to this. So for, I guess, each thing in the previous level, and then for the child and each of the children, if child, add that to the current level, and then say, I guess, because Q was the previous, oh no, so Q's the current, okay. Oops, I have scrolled to not far enough. Q equals current. Yeah, I guess. Sorry, I had to cough there. But I guess that makes sense, right? So he's literally just traversing it iteratively. He's saying for each node in the current level, look at the child, and then if it has a left or right child, add that to the next level, and then the next level becomes the current level. So I think that makes sense. And then, yeah, and then when you get to the final level, whatever's there, just add all the values. Wow, that is just so clever. And once again, here I am feeling like a dummy. But I'm going to go through the solution one more time just to make sure that I understand. So thanks to this guy for posting this expansion. But we're going to look at the previous level. Then we're going to make an empty list to hold everything that's in the current level that we're about to look at. So for everything, for P and Q, so I guess like for each node at the air quotes previous level, look at the child, and then if they have a child, add it to the next level, and then just say, okay, now instead of looking at the previous thing, we're going to look at the next thing, and you keep going until you reach the final level and there's nothing more to look at, and then just return the sum. So that was honestly a huge train wreck. Gosh, that was pretty questionable. But regardless, I hope you learned something. I know I certainly did. You definitely didn't learn how to code from me. But thanks for tuning in, and I will catch you next time on Dragon Ball Z.